Welcome to the video lecture series on finite languages and automata theory. In today's video lecture, we'll be learning about simplification of context-free languages. So this can be done in three different segments. One is removal of useless symbol, and otherwise this is also called as a reduction. The second one is removal of unit productions, or you can say that uh, if you have a non-terminal, only one non-terminal on the right side of the production, then that is called as a unit production. The third one is removal of null productions. This is also called as removal of epsilon productions. So first we will learn about removal of useless symbol. So when a symbol or a non-terminal can be called as a useless symbol in a production. For example, if you have a non-terminal and that non-terminal does not appear on the right side of the production except the starting symbol, and if such kind of non-terminal does not generate any kind of string here, okay, then that is actually called as a useless symbol. So we can see that this is the general idea behind how to identify the useless symbol when it does not appear on the right side of the production. Okay. So we will take out an example for this. So we'll take out an example for this. So find the useless symbol here. So S tends to XB, S tends to AB, and S tends to DB, X tends to A, B tends to BB, and these are the productions here. Okay. Now, how will you actually identify? How will you identify a useless symbol in this scenario? So when you take it out, X actually B appears on the right side. A and B appears on the right side, D and B appears on the right side. Okay, almost all the non-terminals actually appear on the right side. But which actually generates a string? We'll take X. Okay. Now, this X is actually generating a terminal called as A. That means a string, it is capable of generating a string. When I come for B, it can generate BB or B. Okay, finally it can end with a string here. Now, when you take a A can generate AA or it can end with A. So finally, it is also ending with a string or not a terminal here. But when you take up D results in AD, but this is called as a recursive production. Again and again, you will be having a non-terminal called as AD. So it will not stop with only terminal. Okay. If you substitute this production, D can be substituted by AD, and there is no way for substituting this D again by any kind of terminal, because again this D will be getting repeated. So this symbol, this D is actually called as a useless symbol. Okay. So since D is a useless symbol, so D is a useless symbol. So the mechanism here is we have to eliminate this D. Okay. So what we have to do is wherever D is there, we have to eliminate such kind of symbols here. Okay. In the production. Okay. D is actually taking place in this production here. Okay. This production should not be there. Okay. And wherever D is there, that's such kind of production has to get eliminated. Okay. So I will rewrite the production. So after eliminating D here, after eliminating D, we'll rewrite the production. So S can be written as XB, because there is nothing wrong in this production. The next is actually we can replace by AB, but I cannot write DB here. D is called as a useless symbol, so that productions, anything which consists of D should get eliminated. Okay. Then X tends to A, then B tends to BB bar B here, B tends to BB bar B, then A tends to, again we will write A tends to AA bar A. Now this production, I don't want this production, so I simply skip it off. Okay. So whatever you are seeing here, this is called as a final production, result of the final production after eliminating a useless production, isn't it? So D is called as a useless symbol, so that all this connected with D got eliminated. Now we will go for what is meant by we'll discuss another problem which pertains to D here. Okay, another problem which pertains to useless symbol. Okay, let us take a classic example for this. I'll take an example for this. So we'll remove an useless symbol. We will remove an useless symbol here. Okay, so how to remove an useless symbol? So remove uh, remove useless symbol. So we will remove a useless symbol. So how to remove this? So now we will write a protection. So S tends to capital X and Y. Okay, capital X and Y, and X tends to small a and Y tends to small b, and I will write a protection called as T tends to a comma b. Now we have to eliminate a useless protection, okay, useless symbol. So how to do that? So let us assume that the starting symbol is actually S here. From S we can go for non-terminals called as X and Y, and X is generating a string called as A, Y is generating a string called as B, and no way I can reach this T here. T cannot be reached from the starting symbol. So this T non-terminal cannot be reached, and it is not existing on the right side of the protection. So T is called as a useless symbol. So T is useless symbol. So any protection which is connected to T should get eliminated. Okay, so I will rewrite the protections here. So after eliminating, S tends to XY and X tends to small a, and the next is Y tends to small b. So we have eliminated all the protections which pertains to this problem. Okay. So this is the way of identifying a useless symbol in an context-free grammar. Now we'll go for null protections. Okay. So removal of null protections. Removal of null protections. So what is actually removal of null protections? How to do that? So when we talk about removal of null protections here, we'll write with another classic example. Let us assume that I have a protection called as S tends to A, B, C, capital C, and A tends to small a, capital A, and epsilon, and B tends to BB, and C tends to D, small d, and capital C bar epsilon. Okay. Now, first what we have to see here is we have to see which protections is actually giving you the null protection. So, in this problem, A and actually C are actually having epsilon transitions, isn't it? Epsilon protections. So, such protections are called as null protections. So, how to get rid of that? Now, see here, I will start from the first protection, S tends to ABC. So, we'll write S tends to ABC. Put a bar. So don't touch the original protection. Now, which is actually generating an epsilon here? Okay, A is generating an epsilon and C is generating an epsilon. So first substitute epsilon for A. Okay, when I substitute epsilon for A, what is remaining? BC is remaining. A bar. Now, you take up again the first protection. When I substitute epsilon for C now, when I substitute epsilon for C, what is remaining? A, B will be remaining. Now, you substitute epsilon for both protections A and C. When I substitute for A and C, what will be remaining? B will be remaining. Okay. So, this is finally we have done eliminated epsilon for the first protection. Okay. Now, we will get rid of the second protection. So, A tends to small A tends to small a, capital A. Okay. When I substitute this epsilon in A, what will be the answer? remaining is actually A. Okay, when I substitute this epsilon on A, remaining will be A, so I write A. And the next production B does not have any epsilon transitions, isn't it? It does not have any null production, so B tends to BB. So I am not touching this. The third one is C. C is actually having a null production, isn't it? Okay, you rewrite the production for C. C tends to, C can be written as DC. Now, when I substitute this epsilon on C, what will be the answer? Epsilon on C, you will be having the remainder as D here. Okay, when I substitute epsilon on C, remainder is D. Okay. Now, this production is called as the production which does not have equivalent production, which does not have any null transitions or null productions. This is the way of eliminating null productions here. Okay. And the last one is eliminating unit productions. So removal of unit productions. Removal of unit production. So what is removal of unit production? So say for example, if a production is of the form A tends to beta, okay, where beta is actually equivalent to only one non-terminal on the right side. Okay, so what is beta here? So beta, length of beta should be 1, and this beta should belong to a non-terminal. If this is the case, then this is called as a unit production. That means the right side you will have only one non-terminal. Such kind of production should get eliminated. Okay. So we will learn about how to eliminate the null productions here, sorry, unit productions here. So the best idea of doing that is, we will write go for a problem, and we will just eliminate all these unit productions. Okay. So the problem here is, so we'll have S tends to AB, S tends to AB and T. Okay, so we have to eliminate the unit productions here. So A tends to small a, capital A, small a, and B tends to small b, capital B, small b, and T tends to C bar D. Okay. Now we can see that out of this production, only one production is a unit production, that is S tends to T is a unit production, because you have only one non-terminal on the right side. Okay, so how to get rid of that? So the best idea is actually replace this T by its own productions. So when you replace by T by its own production, T can be replaced by C or D here. So we will replace it. Okay, so replace unit production. What is the unit production? S tends to T. Unit production S tends to T. So how to replace that? So we can replace that S tends to, we will write it as AB, and then this T can be replaced by C or D. Okay, so I replace by C or D. Then we will rewrite the remaining production. Okay, so A tends to small a, capital A, and B tends to small b, capital B, small b, and finally we will have T here. T is actually does not make any sense because T cannot be reached now. Okay, but anyhow, right. So this is the way of actually eliminating the unit production. So thanks for watching the video. Have a good day.